The agenda is it's pretty straightforward. Wei is going to share with us some of the insight from a StackRox survey on the state of the Kubernetes and container security. That really good complement to our own Sumo Logic annual modern application survey. Then he will actually share best practices for Kubernetes across both the infrastructure and the application layer. He's an expert in the subject. It's going to be really interesting. And then I'm going to close by giving you a glimpse into the Sumo application for StackRox that we have built together. Give you a sense of what can be done out of the box very quickly by leveraging the two solutions with this out of the box set of functionality. And with that, I'm going to pass it to Wei Lian.
Thanks, Stefano. So I wanted to start off today's talk with highlighting some key observations we've seen when it comes to container security. And at StackRox, we recently surveyed nearly 400 security and infrastructure professionals on topics related to Kubernetes security. And I want to share some of the results because I think they provide a really important context for what we as security professionals need to keep in mind as we think about securing containerized apps. Stefano,
17 minutes.
The clicker. So first we see that the footprint of containerized apps continues to grow. And so we did this survey last fall, and in the span of just 6 to 9 months, across the board we see that the number of containerized apps continues to grow regardless of how much an organization has or hasn't done with work with containers previously. In parallel, we see that far more containers are running in production now, just compared to last year. And this is typically tied to additional challenges around scale and complexity, and that also results in increased security concerns. And yet, those security concerns tend to lag the momentum around adoption of cloud-native architectures that are driven by dev and ops teams, and that's evidenced by this chart. A third of the respondents that we heard from characterize their security strategies as either non-existent or still being planned. Now, while these results reflect variation in terms of specific containerization patterns, one result really does stand out, which is and reinforces what I think most of us already know, which is that Kubernetes has become the cloud-native ecosystem standard for container orchestration. And so, given that, we want to spend time today talking about best practices that you can utilize for securing your Kubernetes environments. And if you're newer to Kubernetes, you want to keep in, these are important considerations to keep in mind so that down the line, you're happy with some of the future ramifications of your choices today. And if you've been actively running Kubernetes for some time, then this gives you a new opportunity to either look at new topics or revisit some of your existing security approaches. And so, as we talk to the best practices as well, I want to just be clear, this is not meant to be exhaustive. This is really just a subset of things you should be thinking about. An effective security strategy for Kubernetes, requires thinking about how you're going to leverage both native platform security controls as well as third-party solutions like StackRox and Sumo Logic. And additionally also ensuring coverage for use cases that span network segmentation and compliance and threat detection and incident response. And that's really beyond the scope of today's talk. And so if you're interested in that and want to learn more or discuss further, please feel free to find me off stage afterwards. Now, let's talk about best practices. And I'm going to cover, talking best practices for infrastructure and then move on to, application workloads. And that line can be fuzzy. There's some overlap, but I think an important delineation or helpful one is that infrastructure tends to have a, separate or longer life cycle, than each app. There are also clearer distinctions. Assets like cluster nodes will map to infrastructure. Artifacts like images will map to, will correspond to your applications. And so here are 5 best practices that we're going to run through for infrastructure first. And the first is really about being ready to upgrade. Thanks to the hard work of the Kubernetes community, including a recently published security audit, there have been a number of key Kubernetes vulnerabilities that have been disclosed. And many of those affect and impact the API server. Many of those affect the majority of versions going all the way back to 1.0. And so the primary way to address those is to make sure that you're staying on a recent version of Kubernetes. And if that presents operational challenges for you and your team, then you may want to strongly consider a Kubernetes service that's offered by a cloud provider to help with automatic upgrades. The next is really think about isolation and the implications of multi-tenancy in your environment. Where does it make sense to segregate and run workloads on in separate clusters or on separate nodes? And then you want to take advantage of the virtual boundaries that Kubernetes enables via native constructs like namespaces. Don't rely on defaults. You don't want all of your deployments going into a single default namespace. You don't want all your pods having open connectivity to each other. And then third, avoiding what we might think of as leaky abstractions, which means minimizing dependencies across those boundaries, compartmentalizing your attack surfaces and avoiding operational confusion. And part of this is when you express your infrastructure needs or your infrastructure requirements programmatically, you want to leverage standard Kubernetes resources, for example, using a persistent volume claim as opposed to depending on the specifics of any given host. The fourth best practice and really a key pillar is thinking about access control. We've seen exploits published in the ecosystem that leverage elevated privileges on the API to compromise components like the Kubernetes dashboard or to DOS the API. And so thinking about your least privilege model and implementing one accordingly is a key best practice. And then the goal is really to take these principles and to codify them and to ensure that they're applied consistently across your environment. And the only way to really do that effectively at scale is to build automation into your cloud-native security toolchains. Now that we've touched on infrastructure, I'm going to move to workload security. And the key best practices here really start with first leveraging operational metadata. Kubernetes has an elegant design that allows you to actually exposes a lot of rich operational metadata should you choose to take advantage of it. So concepts like, for instance, labels tell you about what an application is. Annotations let you add information or tag information about the application. And so that gives you greater context at the outset of what an application is, what it should do, which allows you to then focus and hone in on the security issues or angles that you really care about. The second best practice is to know what's in your images. So ultimately, what's going to execute in a container starts with its image. And so avoiding unnecessary packages or dependencies is a key starting point to reducing your attack surface in these environments. The third best practice is immutability is really a core tenet of these environments, and so you should embrace that. You should plan for your replicas to be killed. You should treat containers as disposable, and you should do so with the mindset that you don't necessarily need the same level of assurance or data fidelity that you might if you were going to do the same with the underlying host. Fourth best practice ties into what we at StackRox think is one of the greatest advantages of Kubernetes, which is the native security capabilities that the platform makes available to you. And so you can start with baseline configurations across network policies or admission controllers or pod security policies. And so that allows you to achieve policy enforcement while minimizing your operational risk. And so thinking about a sensible baseline configuration across your workloads is the best practice that you want to establish early on. And again, you don't want to rely on defaults. A lot of the defaults are open, and the reason why they're often insecure is primarily for operational reasons or backwards compatibility reasons. And then the fifth is, on the previous slide I talked about automation being key to securing your infrastructure from the outset. I think the corollary to that for workloads, because the activity is going to vary from workload to workload, is really to monitor. And monitor with the knowledge or doing so, knowing that you don't have to just watch what happens and understand what's normal. You can leverage the power of declarative configuration via the operational metadata that I referenced. And to sort of highlight the power of that declarative configuration, I wanted to just take a couple minutes to highlight an example to show you how much information you actually have to work with. And we think that a deployment or a stateful set or an equivalent resource is a great place to orient your worldview. It encapsulates a lot of the context you need. The primary resource that we see users typically interacting with as opposed to individual containers. And so here I have just a standard Kubernetes deployment spec with some of the details collapsed so that we can focus on the most important bits. And at the outset, you can glean information about who runs this and what is it, and you can look at labels and annotations. And we see customers having implemented pretty successful or effective labeling and annotation schemes. And so you can tag things with this is the responsible team, or we see things like a chat room or a phone number or department name, whatever you from an operational workflow perspective is going to help your teams. I can see what image is going to be used, what version is it, what registry is it coming from, and this allows me to get an immutable digest of the contents of the image, which then I can use to correlate with other security information that I have. And if we zoom in and dive into the container section, I can then see what process is expected to execute in this container. Have any resource limits been set that may impact or may not impact its neighbors? What privileges and capabilities have the container been granted? Is the root file system writable or is it read-only? What block devices or configs or secrets exist alongside this container? And so you can just get a sense for the picture around, a more holistic picture around the application that you can already get from this declarative metadata that gives you much better understanding that you can then combine with continuous security monitoring to then hone in on the things that you really need to understand further. And so we've just run through a bunch of, very quickly, a bunch of best practices that you can keep in mind as you think about securing your Kubernetes environments. And one key point is as you scale up your environment, you need to think about how you want to successfully operationalize these best practices. And that's where we see organizations turn to third-party solutions like StackRox and Sumo Logic. Our goal is really to jointly do the heavy lifting for you so that you can benefit from these best practices without having to build out completely new security tooling yourself. And so with that, I'll hand it over to Stefano, who's going to give a walkthrough of a new joint solution that our two companies are pleased to have just announced, the StackRox app for Sumo Logic.
Great. Well, thank you, William. Really appreciate sharing some of the best practices with us. You are lucky today because you're going to get a first glimpse at the brand new application we jointly developed on the Sumo application stack. It's an application for StackRox. It comes with very quick mode of integrations and the typical very easy one-click deployment mode. So you can deploy the application very easily. As any Sumo Logic applications, you have ability to customize it and enrich it. You can extend it. So lots of flexibility, but we believe will give you right out of the box and a number of really interesting observability points that you will be able to immediately leverage to monitor your Kubernetes and containers environments. As all the Sumo apps, it is a collection of dashboards, alerts, searches, things of that sort. There's always an overview dashboard that gives you at a glimpse a sense of a state of your Kubernetes and containers state. You'll see common infrastructures across these dashboards. There are 4 that I will go through in this talk from the StackRox integration. Each one of them at the top have single digit very quickly to, at a glimpse, identify the state of certain key aspect of applications. In this case, we're looking at specific violations from total numbers across images, Kubernetes, as well as the runtime. So both your your build, you deploy, and your runtime. Very easy to get a numeric and color-based depiction of a state. In the middle, there is a trend. Violations by severity, so you can get a sense are your violation following a decreasing state as you would expect, or are you reaching the kind of goals that you expect to achieve over time? Every installations, every implementations have of course a lifetime and a natural evolution. And then at the bottom it actually goes into some specific aspect of the security of that environment. In this case, on the bottom right, it looks at the key policies, violations that you are exhibiting at that point in time. Policy is one of the great benefits of utilizing an application like StackRox, then you can codify your best practices from a configuration standpoint into policies, and you have a way to both monitor and enforce those policies across your environment. And then one of my favorite actually panel, it's kind of tacked in on the bottom right side, and it gives you a sense. This is kind of a logical structure that makes a lot of sense to me. From a Kubernetes standpoint of security, it gives you 4 different views on your environment. The first one is your policy. Again, have you hardened your environment properly? Are you getting violations through the policies, the indications that your hardening of the infrastructure has some issues? The second one is vulnerability management. Clearly, vulnerability is a key security aspect for any kind of containerized application. The next one is look at the Kubernetes application itself and see whether you have fully and completely and appropriately configured Kubernetes to be secure. That can become itself a point of attack. And then the fourth one is the anomalous activity. This is a unique capability that comes from StackRox. It's a machine learning driven ability to identify in runtime if your containers are behaving in a way that is anomalous and risky to the environment. It provides a next layer of ML-driven type of detection on your runtime. I'm going to go in the next 3 dashboard next 2 minutes. I'll try to be fast. That goes more details in 3 different aspects of your Kubernetes environment, which is your containers and containers components, the Kubernetes itself, and then your runtime. The image, again, has the same structure, single numeric color-based indications of a state of violations and image components for containers. The middle section looks at your CVE, what are the most common CVEs in your environment, and it breaks them down by severity as well as by components. The next layer looks at severity and looks at clusters. And then the bottom has actually the specific top CVE violations or vulnerabilities that you should immediately pay attention to, as well as give you a trend analysis of the CVEs over time. The next dashboard actually dives into Kubernetes itself, give you a sense of violations across deployments as well as violations across namespaces. Namespaces, of course, is a key logical artifact of how you organize your services and applications within a Kubernetes environment. It will give you a violations by namespace, again, a key concept, severity, as well as look at the number of attacks to your endpoints, your Kubernetes endpoints that get attacked on their own. Again, we're looking at the Kubernetes infrastructure as well as the namespaces. And then the final dashboard I'm going to cover today actually has to do with the runtime. You'll see a very symmetrical division. The top portion looks at runtime violation called malicious versus anomalous. Malicious means these are known process executions that are reconciled to a list of StackRox known process exploits. The bottom portion, again, leverages the ML-driven behavioral-based detection. This indicates there is a runtime that is behaving in a way that is inconsistent, anomalous, or malicious versus a baseline. It breaks it down by these are the top execution errors versus also breaks it down by deployment and clusters. I know this is a lot of information. The key takeaways is number one is Kubernetes comes with its own sets of native controls, security controls. Take advantage of that. Very helpful. Similarly, takeaway number two is the declarative nature of the configurations gives you a lot of information both about the Kubernetes environment, but also about the containers that it controls and orchestrates. And then takeaway number three is as you scale your Kubernetes environment to a point of large magnitude, that you move from an environment of to be in in development versus being into an operational state, leverage technology like Sumo and StackRox that can actually scale and automate the security aspect of a Kubernetes environment. That can give you immediately out of the box a lot of immediate monitoring capabilities across both the containers layers, the Kubernetes layers, as well as the runtime layer. So these are kind of 3 takeaways. Thank you for participating in the last conversation. I think we have a few minutes for questions. If anyone, I have a microphone, I'm playing double role here. If anyone has questions for how to manage Kubernetes containers, StackRox, Sumo, we are happy to take any questions.
So is this available as an application in Sumo Logic?
Is it available in the question is, yeah, is this available in Sumo Logic? Yes. This is part of the launch keynote yesterday about across Kubernetes. So we are providing the discoverability, observability, and security. This is one of the key partners that we'll work with to provide the security aspect of a Kubernetes solution. It's an app that is immediately available to you. Any other questions? With that, please join me in thanking StackRox and William for the presentation. And we'll be on the side if you want to have any individual conversations.